Hi, it's me, Mr. B. Let's discuss domain range and zeros for a minute. We've talked about domain and range before. The domain is the x values, the range is the y values. And we've discussed it in terms of given points on a graph like, 2, 7, 3, 9, 4, -1. We would list the domain as 2, 3, and 4, and the range as 7, 9, and -1. But what happens if we're given an equation of a line like y equals 3x plus 1? If we were to look at the table function for that graph, we would see an infinite number of x and y values. So there's no way to list all of the x and y values. We'd be writing numbers forever. So we have to come up with some other way to do that. We're going to talk about it in terms of the graph, and we're going to define the domain as not only the x values, but how far left and right the graph goes. And the range is going to be the y values, or how far up and down the graph goes. Now zeros are going to be the x coordinates where the graph crosses the x-axis. Y is equal to 0 all along the x-axis, so it's basically the x coordinates where y equals 0.
One of my favorite sports to watch when I was a kid growing up, and even now, is hockey. And this guy right here is my favorite hockey player ever. His name is Mario Lemieux. He played for the Penguins, and his number is 66.
All right, in your notes you have the function k of x equals x squared minus 4, and you have the graph there, and we're going to answer and fill in the 4 blanks there. So type of function, the domain, the range, and 0. So let's start with the type. Because this is a U shape, we're going to say this is quadratic. And in order to tell if it's quadratic from the equation, I have an x squared. So if the highest exponent of x is a square, then it's a quadratic function. All right, so to figure out the domain, range, and zeros, let's hop over to Desmos and take a look at the graph. All right, so here's the graph of x squared minus 4. It looks a little bit different than the graph you have on your paper, and that's just because I'm zoomed in or zoomed out a little bit more. Okay, so when we're doing domain and range, we're going to use a domain tool and a range tool. Now, in this case, I'm going to start with the domain, and as you can see on the left-hand side of the screen, I have an orange line. That is the domain tool. It's a line that goes up and down forever. So it goes all the way up the graph, and it goes all the way down the graph. So if I zoom out, you can see that it's a vertical line that goes on forever in both directions. Now, it actually looks like that orange line intersects the graph way, way, way up here. And I have to zoom way out to see that. And so anytime that orange line intersects the red line, I'm going to beep. So it's going to beep right there. Now, if I started it way over here, let me drag it back over here, then it would beep back there because this U opens up left and right forever. So even though I can't really see off the screen to the left and to the right, that orange line would intersect the red line no matter how far left I moved it, because that red line opens up all the way from the left to the right. All right, so I'm going to start sliding the orange line across the screen from left to right. Anywhere the red line and the orange line intersect, I'm going to beep. All right, so here we go. Beep. Okay, so I'm stopping there just because my screen stops, but if I kept that going, that leading edge of that orange segment would intersect with the red line, and I would keep going on forever, and I can keep moving it out, and that line is going to keep intersecting with the red line. So I'm going to beep all the way from left to right. So in order to write that, I'm going to go back over to the domain, and I'm going to put a fancy squiggly. And you don't have to be real precise about those, but it's not a parentheses. And I'm going to put x such that. Now, that stuff right there doesn't make any difference to the rest of what I'm going to write. This is just formatting. This is called set notation. So I have a fancy squiggly, x such that. Now, here's the important part. Where did I beep? Okay, well, I beeped all the way from left to right. Anytime I do that, I'm going to write this for my domain, x equals all reals. Now what that means is any real number that you can give me, and we learned about real numbers earlier in the class, earlier in the semester, any real number that you can give me, negative 100,000. Okay, well, there's an x coordinate. There's a point on that red line that has an x coordinate of negative 100,000. 52, there's a coordinate on that red line that has an x coordinate of 52. So any number you give me, there's an x coordinate of that number somewhere on that red line. Okay, so that's the domain. It goes left and right forever. And I don't want to list points, otherwise I'd be listing points forever. It's an infinite number of points. So I have to have some other way to write it other than just a big list of numbers. And this is the way to write it. All right, so let's go do the range. All right, so let me turn some of this stuff off. And I'll turn the range on. Okay, so I'm looking at my graph. And now I went from the orange line, which was vertical, and that's the domain tool. So now I have a range tool. Okay, well, everywhere that the green line now intersects with the red line, I'm going to beep. Okay, well, right now the green line is not intersecting with the red line. Okay, so I'm not gonna beep at the point where that green line is, so I'm going to start moving it up. All right, right there, it starts to beep. Okay, so what is that point? Okay, well, it looks like negative 4. Okay, so let me zoom back out. Let me move this bottom point on the green line up. All right, so right there at negative 4. All right, so there's my green line. So as I move it up the graph, I'm starting to beep right now. All right, so I'm going to move it up farther. Beep. I'm still beeping. Beep. And I could keep zooming out, but that red line is going to keep going up forever. So as I move the green line up, I'm going to keep intersecting the red line as I move it up. It doesn't matter how many points I intersect on the red line, just as long as I'm hitting the red line somewhere. In this case, I'm hitting it twice the whole way up, but it doesn't have to be twice. It could just be once. Okay, so I'm beeping all the way from negative 4 all the way up. Okay, so let's go ahead and do the range. So my range is going to be fancy squiggly y such that. Okay, again, that's just formatting. That doesn't really mean anything. Everything that comes after that is going to be what the actual range is. So it's all the y values from negative 4 up. So I have to write that as an inequality somehow. So the way I'm going to write that is y is greater than or equal to negative 4. That means if I looked at the list of y coordinates for that red line, I would never see a number below negative 4. I would see everything from negative 4 all the way up, through 0, all the way up into positive numbers. Okay, so that's the range. And then the zeros, I'm going to get from, let me turn some of this stuff off. The zeros are going to be where the graph crosses the x-axis. I'm going to zoom in a little bit more on there. It looks like it's negative 2 and positive 2. In order to do that, I'm going to hit the line. And I see 2 little gray dots pop up on that line. If I tap on those gray dots, those are my zeros. So my zeros are negative 2 and positive 2. The point down here at the bottom that crosses the y-axis, that is not a 0. That's the y-coordinate. What I'm looking for, or I'm sorry, that's the y-intercept. What I'm looking for is the x-intercepts, negative 2 and positive 2. All right, so let's go back. So my zeros are negative 2 and positive 2. And I can write the zeros like that, or I can write it like this with fancy squigglies around it. What I cannot do is this, because now that becomes the point negative 2, 2, and that's not what I want. So this is not allowed. Okay, so I can either write negative 2, comma 2, or put the fancy squigglies around them.